Hello friends, welcome again. Sumit this side. Most of you would be knowing about me if you are following me on LinkedIn regarding the data engineering content. Today I am going to talk about an extensive roadmap on how to become a data engineer. And I say this is a roadmap beyond cracking interviews because the role should not be just to crack an interview, but to be one of the top performer. So I would be talking about why learn big data, how a data engineering pipeline looks like in production, and a successful roadmap to become a data engineer. These are the three things I would be talking about in this video. So if I am talking about a roadmap to learn big data, then you should ask yourself why big data? There are so many technologies, then why just big data? I would say these are the reasons that number one, you would get a much better CTC compared to other technologies, which is the most important factor. Let's say you are working in testing domain, mainframes, or let's say Java developer, be it whatever. If you enter into big data, you can get a much higher CTC. Not just that, your future would be secured because today everything is related to data. Big data is one of the most trending technology, and people working in big data get a much higher CTC compared to other technologies. I will first talk about an end-to-end pipeline that you will work on in your companies, and then I will rate each technology to this pipeline. So let's get started. Initially you have multiple data sources, right? That means the data will be in form of files, or might be data is coming through some sensors, or data can be coming from some databases, data warehouse, can be many things, many tools, many technologies, right? So data will be coming from multiple sources and can be in multiple formats: structured, unstructured, semi-structured. Now you as a data engineer would have to take this data from all these places and get it to your storage layer. Now this storage layer will not be something like your normal storage layer, like your laptop storage. You are talking about huge amounts of data. So you want to talk about distributed storage or a different kind of storage which can manage this much of data. So how do you get this data? You talk about one ingestion platform, right? Or ingestion framework, which has the capability to take the data from these sources and bring it to your storage layer. Which storage, which ingestion, we'll talk about later, but understand the flow. Multiple sources, you get the data using some tool or technology and bring it to your storage layer. Now, once the data is in your storage layer, you would process it using one of the processing framework, right? That's where you would learn one of the processing framework. Now, this will not be like your normal Python program or a Java program. If you write a normal Python program or a Java program, that has the tendency to solve the problem on a single machine. But when talking about big data, you are not limiting yourself to just one single system, right? So this is very, very important. Now, once you have processed the data, you want your reporting team or visualization team to slice and dice and even show it in a visual form. So that's where you want to keep the data in a serving layer so that your visualization team can take it forward from here and show the data in the form of bars, charts, whatever it is. So this is how a typical data engineering pipeline looks like. And I would say, think logically that this pipeline would remain the same. The tools and technologies related to this might change over time, or the technology stack will evolve over time. So that's where, to create a logical foundation, make sure you understand this pipeline well and then relate your learning with this pipeline always. Now, if I have to talk about the roadmap to learn big data, first you should know few of the very essential things. These things are not directly related to big data, but you should know these things in order to start your learning with big data. Because this forms the right essentials that everyone should know. If you do not know, not a big deal, you can learn that anytime. So you see here we have Python, right? Basically, you should know one programming language. Earlier, there were days when you should know Java in order to learn big data, but nowadays those days are gone. people are inclined more towards Python, and Python provides a very, very good support. So I would say learn one programming language, preferably Python. And Python is one of the easiest language to learn. Now, it's not that you spend 200 hours of learning to learn a language. No, you're not learning a language that way. Rather, you are learning Python for data engineering, which you can even do in 20, 30 hours, right? So it's not too extensive learning of a language, because language does not make you a good developer. Logic makes you a good developer. Language is something just to interact with the system and learn it to whatever extent required. Might be in Python, you would talk about some data structures like lists, maps, things like that, right? And fundamentals of it, like how a for loop work, while loop work, and some of the other things. So I would say 20, 30 hours of learning can give you a good exposure around Python. Now then you would learn some basic Linux commands. Linux commands are a must to know, and it should not take much time. Hardly there would be 30, 40 commands which we generally use. You can learn that, and as and when required, you can learn more as per your need. Now, SQL is a important thing, and all the data engineering interviews would ask you certain level of SQL. SQL, you should know easy, medium, and to some extent the hard level also. Now, things which are generally asked in SQL interviews could be related to joins, group bys, and at the max windowing functions, which is very, very important. Now, a lot of people ask how important is DSA for data engineering. I would say few of the top companies would ask DSA, right? It's not that every company will ask, few of the top product based companies will ask, but it will not be at the level of software engineering. So I would say easy to medium level is sufficient. So you can start with finding time complexity, arrays, to some extent linked list, and sorting and searching problems. So do not go too extensive on it, or do not deviate yourself so that you keep on learning data structures and do not know about big data or data engineering, right? So DSA is required, but not to the extent of software engineering. I would say easy to medium level should suffice your need. Now we have learned the essentials part of it. The second thing that you should think about learning is you should have a rock solid foundation around distributed storage and distributed processing fundamentals. Now, it's not that you always get hooked to a lot of tools and technologies. Rather, fundamentals play a very, very vital role. Given a problem statement, how you store the data across multiple machines. Given a problem statement, how multiple machines can solve that problem. That thought process is super, super important. That's where you can start your learning with HDFS for distributed storage, where you talk about block size, replication factor, things like that. And you talk about MapReduce theory. I mean, you might be thinking MapReduce is not required these days. You are true. But the thing is that MapReduce practicals is not required, but theory still plays a very, very vital role. How a map works, how a reduce works, what is shuffling, what is sorting, why is this required? Because even today, the latest frameworks on processing side works around these fundamental concepts. So MapReduce from a theory perspective is very, very important, and you should make sure you learn it well so that you have a good grip around distributed storage and processing fundamentals. Okay, so now we have learned the data engineering essentials. We have learned the distributed storage and processing fundamentals. We have a rock solid base to learn data engineering tools and technologies now. So let's get started with that. Now, your pipeline looked like this. You have multiple sources. You then have to ingest the data to bring it to your storage layer, right? Which is called as data lake, by the way, right? And then you process the data using some processing framework. So in this list, we have multiple sources, and you want to first bring this data to your data lake or to your storage layer. So how to get that? You need to learn one of the ingestion framework. And I would be inclined more towards Azure Cloud, because Azure Cloud is super trending these days. Even though we have three major cloud providers, AWS, Azure, and GCP, but the way the big data world or data engineering world is moving, I would say Azure cloud is becoming more prominent. And if you see most of the job openings, they would ask for Azure cloud. Any of the cloud is okay, but if you are learning new, Azure cloud is recommended. So I would say in terms of Azure cloud, you try learning ADF, Azure Data Factory here, where you can get the data from multiple sources and bring it to your storage layer, right? And now where you will get the data after ingestion to your storage layer, which is distributed storage or the object store, right? When you talk about your HDFS, which is Hadoop related part, which is distributed storage. If you talk about Azure cloud, then you have Azure Data Lake Storage Generation 2, ADLS Gen 2, which is object store. And you can also call it as data lake. Now, once you have got the data to your storage layer, which is your data lake, right? You would think about processing it using some processing framework. So how do you process this data? I would say, even though it all started with MapReduce, but learning MapReduce theory is good enough. In terms of practicals, you should learn Apache Spark, which is super important these days. If you are going for a data engineering interview, 60 to 70% of the questions might be just from Apache Spark. And I would say this is super important. Put special focus on it when you are learning it. You would start learning with RDDs, which was the earlier thing, right? But now the creators of Spark itself say you should be working around data frame or Spark SQL, which give you right performance, right? So you might think about learning RDDs to some extent, but most of the focus should be around data frames and Spark SQL. However, in interviews, most of the time they will ask you to code in data frame style because SQL anyone can write. So when you start writing in Spark SQL, they would say, okay, can you write it in data frames, right? Using data frames. So that's where you should focus more on data frames more than anything else. Now, if you are going for interviews, most of the times they ask you questions around optimization techniques, right? They would say, okay, do you know partitioning, bucketing, file formats, compression techniques, catalyst optimizer? How do you perform a join on two large table? How can you optimize that? What is a broadcast join? Things like that. So we have learned the data engineering essentials where we have covered Python, Linux commands, SQL, and to some extent DSA. Then we have learned distributed storage and processing fundamentals, which are super important to give you the right base. And now the third thing that we were learning is the tools and technologies, where at this point we have learned, let's say, Azure Data Factory for ingestion. We have learned ADLS Generation 2 for your storage. If you want to talk about AWS Cloud, then Amazon S3 is the option, right? And then in terms of your ingestion, if you want to learn in AWS, then it is AWS Glue, right? So I would write it here. For ingestion, we have Azure Data Factory in case of your Azure and Glue in case of your AWS. Okay, in case of your data lake storage, we have ADLS Generation 2 in case of Azure and Amazon S3 in case of AWS. Now, Spark is again open source where if you learn this, RDD, data frame, and Spark SQL, which can give you the right balance. Now, talking about Databricks, which is becoming more and more important these days. You think it this way, that this is Spark on cloud or a managed Spark cluster on cloud. On a click of a button, you can create a Spark cluster. And even this is created by the creators of Spark. And they say this is more optimized, right? So think that this is a better version of Spark on cloud, which gives you better performance. Not just that, there are some special concepts like lake house and all, which again gives you an edge compared to normal raw version of Spark. So I would say learn Databricks, and the learning curve should not be that high if you have spent good amount of time on the plain vanilla Spark which you have learned earlier. So with this, we have ingested the data, we have stored the data, and we have processed. Now talking about serving layer. After processing, you want to keep the data in a serving layer so that your visualization team can take it from there. So now in terms of serving layer, your databases or data warehouse is the best fit, right? So you would learn one of it, and basic concepts around acid properties or normalization versus denormalization, slowly changing dimensions, all of this you can learn so that you get little comfortable with this, right? So with this, you will be able to create an entire pipeline. Now, one thing is left. The thing is, you want to orchestrate this pipeline that, okay, I want to invoke this activity once this is done. And I want to invoke this pipeline at 8 p.m. every day. So you should know one orchestration framework like Airflow, or again, Azure Data Factory can also help you with your scheduling and orchestration in cloud. So learn either Airflow or Azure Data Factory, whatever, based on if you're on cloud, learn Azure Data Factory. If you are doing it on premise, then you learn Airflow. Any of it is fine. So again, do not get too hooked with the tools and technologies. It will keep changing. But this entire pipeline, the thought process will never change, right? That's where I'm saying 2 years back, there would be different tools. Today, there are different tools. Again, 2 years later, there will be different tools. But make sure you get the concept well, that what you are doing and in which stage of the pipeline you are doing that. Now, again, to get that extra edge when you are going for interviews and all, make sure you learn how a project is handled using agile methodology. What is a sprint planning, things like that. You should know little bit about Git commands, Git and GitHub, which most of you would be knowing, and something around unit testing. If you are talking about PySpark, then you can learn PyTest framework, and how to deploy your code using CI/CD, right? So things around that, Jenkins and all of those things. You would be knowing that. If not, I might create a separate video to talk little more detail around it. But these things are required in order to go for interviews. Now, we have learned all whatever is required, and by this time we know how to handle a batch pipeline. That means once we have a file, right, then we know how to handle it, how to process it, and we can create the entire pipeline. Only thing left is to create one or two projects so that you can showcase in your resume. So in a project, you might be working on one or two aspects only, but as a good data engineer, you should be aware of one tools around each of these aspects so that you can build your own end-to-end pipeline completely from scratch, right from the beginning till the end. So make sure you do 1 to 2 projects and try to implement whatever you can. Now, after this point, I feel you are good to start with interviews, because not everyone asks you the streaming part. Of course, streaming part is left, but 70 to 80% of the requirements would be just on the batch part, and I think you have done good enough, and you have a rock solid foundation now in order to get started. You can start giving interviews, and simultaneously you can start preparing for the streaming part, where you might talk about Spark structured streaming with Kafka, right? This is a really solid combination. And since you are more inclined towards Azure cloud, better to learn Azure Event Hub here. And since you are learning Databricks, in Databricks you can learn autoloader and Delta Live tables in order to get that completeness around, right? But I would say, even if you do not know this part, still a lot of the companies would be looking to hire you, right? Because it's not that every company would need streaming part. Only thing is that if you do not know something, do not mention in your resume, right? If you put something which you do not know in your resume, people would ask that, and the moment you get stuck, the interview is kind of over. One last thing that I would like to tell. If you are a really senior person looking for architect position, knowing about multiple clouds is the need, right? That means we were inclined more towards Azure cloud, where we have learned your data lake part, we have learned about Databricks, we have learned Data Factory, we have learned Event Hub, and you can even learn Synapse Analytics, right? So that you know the Azure part well. But it's better to know at least one more cloud to at a higher level. So I would say You can learn AWS cloud, where you can learn things like S3, right? EMR, Elastic MapReduce, Redshift, right? Athena and Glue. All of this you can learn, at least whatever I can think at a high level. So if you are someone with 15 years of experience, then industry expect that whenever you are designing a solution architecture, it's not that you are limiting yourself to just one cloud. Rather, you should be knowing at least to some extent about another cloud. So this is where I am saying this might not be required for everyone. If you have just 3 years of experience, not required. But if you have huge experience and you want to be a solution architect and all, definitely if you know a broader technology stack, then you can use that knowledge in order to design a solution architecture. Now, this is such an extensive roadmap that why I'm saying this, because I have trained more than 10,000 people all across the globe, and this is one of the proven roadmap where more than 10,000 of students have benefited out of it. And my students are right now working for companies like Google, Microsoft, Amazon, Walmart, and you name a company, more than 10 of students would be there, right? So this will not just help you to crack a company, but this will help you to be one of the top performer, because in the end, you do not learn a technology just to crack an interview. You learn a technology to be really good at it. You learn a technology so that your manager appreciate. You learn a technology so that you do wonders there, right? So this is such an extensive roadmap. Follow this, and I'm sure this will give you the best results. All the very best, and I'm sure after 6 to 8 months, definitely you will be in a position where you can follow this and you can get success. By the way, I teach big data to working professionals. In case if you need a guided path, you can even consider looking at my program. And this should take around 30 weeks for you in order to grab it fully. Thank you all.